In this Rhino beginner's course, you'll learn all the basics needed to get up and running with the program. Part 1 covers the user interface and methods of moving objects, followed by ways of creating basic geometry in Part 2. In Part 3, we'll compare NURBS, meshes, and sub-D geometry, and then practice layers and materials in Part 4. Parts 5 and 6 focus on translating 2D curves into 3D forms and the use of modeling aids. We'll then explore construction planes, command shortcuts, and OSnap options in Parts 7 and 8. In Part 9 and 10, we'll dive into advanced rotation, scaling, Booleans, and chamfers. Finally, Part 11 covers arrays, flow commands, and transformations. My name is Joe Miser. I'm a sculpture professor, and I've been using Rhino in my creative work for the past 15 years. When I first began using Rhino, it was for planning projects that I would later build by hand. Eventually, I transitioned to designing forms to fabricate with tools like 3D printers, laser cutters, and CNC routers. I've also used Rhino extensively to create virtual forms that I've then rendered as photorealistic images, or exported to Unreal Engine for virtual reality projects. Rhino is an excellent CAD program because it has an intuitive user interface, it enables a highly flexible workflow, and it supports the creation of complex hard-edged as well as organic 3D models. While designing this beginner's course, I focused on the commands that I use the most in my own modeling. In the classroom, I've seen that beginners learn best by doing, so all of the segments are in exercise form. That way you can follow along on your own machine. So without further ado, let's get started.
In our first Rhino exercise, you'll get some practice with moving and rotating geometry, and learn to use viewports to understand where things are in virtual space. These fundamental skills will help you use Rhino more efficiently going forward. In this exercise, the Parthenon has fallen down, and it's your job to rebuild it. The blue lines show where the parts need to go. So that you can follow along on your own computer, you'll want to download the exercise file from the link in the description. In case it's helpful to know this, I'm working with Rhino 8 on a PC. No worries if you're using a Mac. The interface is very similar across platforms.
In Rhino, there are 3 ways of moving the camera. The first is to hold the right mouse button and drag to orbit, or we can pan by holding Shift and holding the right mouse button down, or we can zoom, and my favorite way of zooming is to hold Control, hold the right mouse button down, and then move the mouse forward or backward. Or if you have a mouse with a wheel in the center, you can just roll that forward or backward to zoom. It's also helpful to know how to put something in the center of your orbit. And you can do that by selecting an item and then type ZS for zoom selected. Or if you want to, say, see how this pillar relates to the platform, we can select the platform, hold Shift, click on the pillar to add it to our selection, and then type in ZS. Now, if we look in the top left corner, we'll see that we're right now in the perspective window. And so we can change this to the 4 viewport layout by double clicking on perspective. In the 4 viewport layout, we have also the top, front, and right viewports in addition to perspective. And we can change the shading mode in any of these windows by just going to the viewport name and right click on it. And you could set it to wireframe, for example, which gives this transparent representation of the form. Or if we change it to ghosted, that's more of a translucent representation. Or rendered will give us more of a shadowed kind of opaque representation of the form without the wireframe. Generally, I tend to work in shaded most, but there are occasions where it's useful to switch. Something else I should mention about the 4 viewport layout is that you can change the size of each of these viewports if you want to by just dragging around the dividers between them. And if you ever want to switch back to the standard even quadrants, you can just come up under the standard menu here and double click on the 4 viewport button. And we can also get back then to our full screen perspective window by just double clicking on the viewport name. The first method I'll show you for moving items in Rhino is to use the gumball. And so if we select an item, right now the gumball is turned on already, so that's why we see the widget come up. If you don't see the widget, it means you need to enable gumball by just clicking on this button down here. And while we're looking at the lower menu, I'll also mention that we don't need ortho and we don't need grid snap, so let's turn those off. So now the gumball is turned on. If we grab one of these arcs, it will let us to rotate an object. If we say use the red arc, it's going to rotate along a different axis. If we use one of the arrows, it will move the object along a particular axis. Or you can see that little like window pane thing right there. If we grab that, it will move the item along a plane. So right now we're moving along the XY plane. If we orbit down to the side, you'll see that a different one of those window pane things pops up, and we can use that to move the item now along the ZY plane. We can also use the gumball to scale an item. So if I grab this, it will scale one-dimensionally, which would distort the form. Or if we hold Shift and drag, it will scale the item uniformly. We don't actually need to change the scale of any of these items, but just so that you know, that's how you can do it. And if we come down to the bottom where the gumball menu button is and right-click on it, right now it's set to auto reset, which means that every time we click away from the object and then click back, the gumball is going to have realigned itself with the grid. There are some times when it's actually helpful to be able to change the gumball to line up more with the object. And so if we, let's turn this off. And what I want to do is rotate the gumball without affecting the object. And so I can do that by just double clicking on that handle. And then I can set this to be so that the arrow is lined up with the form. Let's run through a quick example together so that you can see how the gumball can be used to move the pillar into place. And so we'll go to the top viewport and get it to be fairly well lined up with the grid from that vantage point. And then we'll go to the right viewport and check it there. And that's pretty close. Let's go ahead and stand it up. And one trick for rotating in 90-degree increments, you can see like, it moves about freely right now. If we hold Shift, it will toggle ortho and turn it on to allow it to snap 90 degrees up. So now we can go so that we're in perspective looking down on the form and move it down in space some. And now I'll type in ZS to zoom selected. Scoot it over a bit. And there are more precise ways of moving things around. I'll show you some methods toward the end of the tutorial. But for now, it would be good to go ahead and pause the video and move some items into place so that you get familiar with how the gumball works. Let's talk about a few other commands that will be useful in this exercise. The first is Control-Z, which is just undo. And we could even step back several steps if we need to. Or if we press Control-Y, it will repeat the last actions we took that we just undid. Or we can copy-paste with Control-C, Control-V, and then we could drag this over. Another way of copy-pasting is to select an item and then press, click and drag on an arrow and just tap the Alt key. And we can also isolate things in different ways. So if we want to only see this pillar and the blue outline, we can select that pillar and type in invert and hide. Or if we want to bring everything back, show. Or we can select the pillar, invert, and lock. And that just makes it so that we can't click on these items. If we want to just make it so that we don't disturb the other parts as we're moving this into place. Lock can be helpful for that. And as you probably guessed, we can just type in unlock to restore everything to its previous state. And you could accidentally initiate a command when you're working in Rhino and then be confused about why the gumball isn't working anymore. So if we were to, for example, accidentally push Control G, right now in the command line it says select objects to group. So Rhino wants us to select 2 items and press enter, and those things are now grouped together. But suppose that that wasn't a command we wanted to run. We could just escape out of the command. So just know if you get stuck, take a look up in the command line and see if something is running. We talked already about turning off these menu buttons at the bottom. I should also mention, though, that we can toggle the grid by pressing F7. So if we want to hide it or show it in any of the viewports, we can do that, F7. And I want to mention a couple of methods for selecting items too. So if we want to use the lasso to select things, we can drag from left to right to select only those things that fall totally within the lasso. Or if we drag from right to left, it'll select everything that the lasso touches. And so that's useful if you want to, say, grab this this little box in a hurry. You can just do that. We can also select an item, as we talked about before, and we can add to that selection by just holding Shift, or we can hold Control to deselect anything from our current selection set. Now that you've had a chance to practice with the gumball, you've seen that it's a great way to quickly move something where you want it, but it's not super accurate. And so there are some more advanced methods that I think you'll find useful. Let's cover first the move command. And so I'll select this item, I'll invert the selection and hide so that we're only looking at this box. And then we'll select the box, and let's turn on our object snaps. So down at the bottom on this menu, I'll click OSnap. And we want to have the end snap turned on. We'll also use the intersection snap. And I guess that's good for now. So we'll go ahead and type in move, M-O-V-E. And the point we want to move from is the bottom left corner. And the point we want to move to is right there. And so now we have that corner lined up, but we need to rotate it into place. And so we can use the rotate command, also using the snap. And we'll snap to the end. And it's asking in the command line for the angle or the first reference point. So we'll go out here to the end, and then we'll just rotate it over and snap it that way. You should be aware, though, that the rotate command works in conjunction with the XY plane. So if you're trying to rotate something up in space this way, you would need to change to, say, the front viewport, possibly. Let me show you an example. So I'll bring everything back, show. So if we want to rotate this item up this way, we would need to do it from this vantage point. So I'll use the end snap, and I'll come to this end, and then we can rotate up. And I told you before that we can hold Shift to temporarily turn ortho on. So that could be a useful way of snapping now to be in line with the grid. And we could do the rotate command again from the right viewport, from the end to the end. You could also use center because the object is has a circular top and bottom. And I'll hold Shift to make it vertical. Another command that I find really helpful for moving complex objects into place is orient 3-point. So let's select this item, we'll invert the selection, we'll hide this stuff, and then we'll move this Let's get it sort of close to where it needs to be. Blue. Move that up. Rotate it this way. You don't have to do this step. It just makes it a little bit easier to see what you're doing. Yeah, that should work. So now orient 3 points. And you can see what I'm doing up here in the command line. It's going to ask me a couple of questions. The object I want to orient is this. So now I'll press enter. Reference point 1. Let's go from bottom left, bottom right to top. So again, we want to put it up here. Bottom left. I have my end snap on, by the way. So I have my object snap turned on, and I have my end snap enabled. Bottom left, bottom right, top. And that's it. At this point, you have all the information you need to be able to reassemble the Parthenon using some of the more advanced move methods that we just covered, including the move command, rotate, and orient 3 point, along with the copy paste command, should help to speed up the process quite a lot.
This video will introduce you to some of the geometry types used in Rhino. These are some of the basic elements you'll use to create and manipulate 3D models.
In Rhino, one of the simplest types of geometry we can work with are curves. Let's create some together. If we come up to the main toolbar here and click on Polyline, you'll see in the command line it says it wants us to define the start of the polyline, so we'll left click. And now it's asking for the next point of polyline, so we'll click again. And since we're finished, as it says in the command line, we can push enter when we're done. So now we'll create a control point curve. So we'll click on this button, and I'm going to click 4 times to just create a curvilinear line. And now let's create a circle. So we'll click on the first button in the second row, and in the command line it wants the center of the circle. I'll left click, and now we have to define the radius, so we'll click again. And finally, let's create a rectangle. So we'll click on this button, and the first corner of the rectangle we'll make here, and we'll click again to finish that command. In Rhino, any linear geometry is considered a curve, so even this straight line is known as a curve in the program. Now, curves can be open or they can be closed, and curves can be modified. So if we select this rectangle, for example, and explode it, it says in the command line that it was exploded into 4 segments. So we can now select these individual parts and do something with them. On the other hand, if we select the circle and run that same command, explode, it says that it cannot explode single curve segments. So not all curves can be broken down into smaller parts. Curves can also be joined together, but before we run that command on these 4 curves here, let's take the lower one and move it down just a little bit to illustrate something. And then we're going to use our lasso to select all 4 and join. And in the command line, it says that 4 curves were joined into 2 open curves. So the top 3 are together now, and the bottom one is separate because the ends didn't meet up perfectly. But we can put it back together so that we can run the join. So let's run the move command and make sure that our OSnaps are turned on, and make sure that the end snap is enabled. And we'll snap from this end to this end. And so we could join this up into the rectangle that we started with, but I want to show you something a little bit different. Let's take these 4 and run the extrude curve command and go up to about here. And if you can't see the surfaces, it may be because you're in wireframe mode, so just make sure that you're switched over to shaded. Now let's take the parts that we just created and shift them over some. So I'm going to orbit down so it's easier to grab this by the top with the lasso. And we'll just scoot it over some with the gumball. By the way, if your widget isn't showing up, just come down to the bottom and turn on the gumball. Let's actually take this and make another copy. So I'm going to drag over and tap the Alt key to make a duplicate. Let's now join these together, the one on the far right. And And then let's select that and run the cap command. Let's take a look at what we just made. We made some curves. We made a polycurve, so curves that are joined together. We have now a poly surface here, so 3 surfaces that are put together. We have a single surface, and we have a solid on the far right. A solid is any form that is totally enclosed, so that if we were to orbit around and look at this from any angle, we wouldn't see a hole to the interior. Earlier, we talked about how curves need to meet perfectly at the ends to be joinable. And the same is true for surfaces. So if this were to be scooted over slightly, the join would fail. In Rhino, one of the ways that we can modify curves is by turning on their control points. So if we select all of these curves and press F10 or type in P on in the command line, we can now grab these points and we can reshape these curves. And once we're satisfied with whatever change we've made, we can press F11 on the keyboard to turn the points off or type P off. Surfaces can also have their control points turned on. Let's give a quick example of that. As a first step, let's take this control point curve that we created over here and run the extrude curve command. Extrude curve, and bring it up to about there. Now there is a little problem with turning the points on for this and this surface. It is that these are technically extrusion objects in Rhino. So if we turn the points on, we're going to get kind of a weird result where there's just going to be maybe 2 points in space. We really want to turn these into regular Rhino geometry. So let's run the convert extrusion command. And let's set delete input to yes. So we'll just press enter. And so now if we select these 2 surfaces and press F10, we have points that we can move through space to change the shape of the surfaces. If we select this solid poly surface we made earlier and press F10, in the command line it tells us that it cannot turn on points for poly surfaces. So this is something you need to be aware of when you're building in Rhino, that once you join multiple surfaces together, they can't be modified in the same way with control points. But there is a different way that we can change this box further. So if we take this and let's make a copy of it. So I'm going to drag over with the red arrow. I'll tap Alt to make a duplicate. Actually, let's give ourselves a little bit more space. Now, if we hold Shift and Control, we can do a subsurface selection. So that means that we can grab just that single surface on the box and change it. We can change this top one. Or you can also, instead of grabbing a surface, you can grab an edge. Or you can even grab a single point and change it. So with sub-selection, it's possible to further modify poly surfaces. You can get some weird results with more complex objects. It wouldn't necessarily bend so smoothly. It might give you some kind of weird wrinkles and other defects that you wouldn't want. Earlier, we established that we couldn't turn the control points on for this solid poly surface. There are some special circumstances where we can turn control points on for solids, though, and that is in the case of single surface solids. And so if we come up to the solid creation button on the left here, and let's go down to the lower right corner of it where it says Cascade Solid Creation and click on that. And let's actually dock this by grabbing the top of this button, this menu button, and bring it over. And now we'll create a sphere. And let's also create a torus. Now we can turn the control points on by selecting them and pushing F10. And we can now deform these items. So I'll select these and I'll hold Shift to scale this up uniformly. Or in the case of the torus, let's select one side and move it up. Maybe rotate it some and then scale it. Another way that we can modify geometry in Rhino is with a trim command. So if we select the rectangle that we made earlier and run the planar surface command, that's planar SRF. That will give us a plane that we can move over with our gumball. And let's rotate this up. Oop. to be more vertical. And I'll hold Shift and grab on one of those scale handles to make it bigger so that it intersects fully with the torus. And now let's run the trim command. So TRIM, and the cutting object is the plane, and it's prompting us to press enter after it's selected. And now it wants us to select the object to trim, so we can select the parts of the torus that we want to get rid of. And we press enter to finish the command. And now that we're done, we can take this plane and delete it. And what's interesting about this is we can now get a curve from the torus. So if we select it and run the dupe border command, so that's DUP border, it will give us a curve exactly along the open edge. And if we then press Control-C, Control-V to copy paste and bring the new one out and scale it up, I'll hold Shift to scale it uniformly. And now let's hold Shift and click back on the original curve. We can run the loft command, LOFT, and that will give us a surface between those two curves. The reason I wanted to show this final example to you was to illustrate that in Rhino, we're not stuck just working from curves to surfaces to polysurfaces to solids, but we can instead take solids and extract curves from them to continue building.
The main idea I hope you'll take away from this video is that in Rhino, we have the flexibility to work back and forth between curves, surfaces, and solids. This is part of what makes it such a useful CAD program. In the last video, we worked with curves, surfaces, and solids. Those were all types of NURBS geometry. What does that mean? NURBS stands for Non-Uniform Rational B-Spline. It's the name of the math used to create a smooth surface. If you're interested in learning what Rhino is doing under the hood, you can read several pages of info about NURBS math and history on Wikipedia. A key reason Rhino has traditionally been a NURBS-focused program is that many of its users need to be able to create infinitely smooth surfaces, for example in fields like product design, architecture, and marine engineering. Another advantage of NURBS surfaces is that they are easy to modify. Despite Rhino's NURBS focus, you can also use the program to work with meshes and with sub-D surfaces. We'll talk about meshes and sub-D surfaces later in this video. From this video, you'll gain an understanding of how NURBS, meshes, and sub-D geometry differ in Rhino. This will help you in the future by enabling you to choose the best modeling technique for the task at hand. Let's take a closer look at how NURBS works in Rhino.
To get started, let's create a sphere. So we'll go over to the left to the main toolbar, and we'll hover over the box button here. We'll go to the lower right corner of that button and click on it, and that opens up this sub menu, and we can click to create a sphere. And now the command line is prompting us to define the center of the sphere, so we can click anywhere and click again. And I'm going to move this up above the construction plane just to make it a little bit easier to see. If we select the sphere, we should see the gumball pop up. If you don't see it, it just means you need to click on this button down here. And we'll drag over on that red arrow and just tap the Alt key to create a duplicate. And now let's select the first sphere and run the rebuild command. And in the context menu here, we see the point count listed for the UV coordinates at the top and a degree listed at the bottom. Let's change the degree to 1 and 1. And now that we've made this change, the degree 1 sphere is quite blocky in comparison to the degree 2 sphere. So this demonstrates simply that the higher the degree, the smoother the form. You won't often need to change degree while you're modeling. We're looking at this just so that you'll understand how NURBS works. The next thing we'll do is change something about the UV coordinates of the right sphere. But before we do, I want to mention that when we're working in Rhino in the perspective window, we have in the lower left corner an axes icon that shows us a preview of the direction of the x-axis, which runs left to right, the y-axis, which runs front to back, and the z-axis, which runs vertically top to bottom. So anytime we create a new piece of geometry in Rhino, the program has to keep track of that object's location in terms of x, y, z coordinates. It also needs to understand what's happening on the object's surface, and the way that it does that is in terms of UV coordinates. So in the case of the sphere, V probably in this case runs top to bottom, and U probably runs left to right. But it's kind of arbitrary, the direction of UE coordinates, because if we were to rotate the sphere, now we've just changed their orientation in space. Now let's rebuild the right sphere. So we'll select it, run the rebuild command, and we'll set the point count to be double what it was initially. So we'll set the U count to 16, we'll set V to 10, and let's set U and V to remain at 2 as it was when we started. Press OK. And now we have many more points that we can modify. So if we select the sphere and push F10, then go into the top viewport and use the lasso to select multiple points. Then come back to the perspective window, hold Shift on the keyboard to scale uniformly and grab on one of the scale handles of the gumball. We can then bring those selected points in all at once to make this look like a gourd or some other organic object. There are some cases like this where we have to add additional points to achieve the results that we're looking for. But as a general rule in Rhino, we want to keep the point count as low as possible on NURBS geometry, just because it's easier to then edit the objects. Now let's change gears and talk about meshes. First, we'll need to turn the points off by pushing F11, and then we can select both of these items and just run the hide command. Now we'll open up the Mesh Tools panel at the top. So instead of the standard one, we'll switch over to Mesh Tools here. On the left toolbar, we'll click on the Mesh box to create one of those. And we'll create a sphere. Just like with NURBS geometry, we can select the meshes and we can push F10 to enable the points to be edited. But in this case, because we're dealing with meshes, these are actually vertices instead of control points. So we could, just as an example of how we can edit this, we can use the gumball to flatten out this side of the sphere, or we can grab a couple of vertices on this side and drag these up into space. What you'll notice about this deformed mesh is that the result looks quite jagged. And that's because Rhino doesn't use the same kind of smoothing algorithm on meshes. So for that reason, I usually prefer to work with NURBS or sub-D surfaces in Rhino. And if I'm going to do work on meshes, typically I'll switch to a program like ZBrush or sometimes Mesh Mixer. Now let's talk about sub-D modeling. So we'll select the objects that we just made and hide them. And then we'll switch from Mesh Tools at the top over to sub-D Tools. Now let's create a sub-D sphere by clicking on this button. And we'll click a couple times in the viewport to create it. I'll move it up above the construction plane. And it doesn't look very different from a NURBS sphere. But if you push the Tab key on the keyboard, it switches it over to box mode. Tab again puts it back into smooth mode. Another interesting thing we can do with the sub-D sphere is to create a smooth extrusion. So if we hold Shift and Control on the keyboard, we can select the faces then on the top. And we will create the extrusion by pulling up the gumball, and then we'll hold Control on the keyboard, and then we'll let go of the left mouse button. You have to do it in that same order. So drag the gumball, hold Control, let go of the left mouse button. And by doing that, we moved the faces up, and we also added this new edge loop. Let's build on this simple sub-D form to make a kind of an abstract representation of a cactus. And so we'll extrude up a couple of times here. And the point is just to show you a little bit of what we can do with sub-D. Bring this up some. And I don't like it that it's so wide here. I'm going to come back and hold Shift and Control and select that whole edge loop at one time. And then if we hold Shift on the keyboard, the gumball will then scale uniformly. Let's do another extrusion on this side. So we'll bring this up, we'll rotate it, bring it up again. And we can even do an extrusion to the interior. So we'll grab this, go in, shift it over some. And we don't have to just do extrusions. We can also just simply grab a face and then relocate it in space. Or we can grab an edge. I'm holding Shift and Control when clicking. We can even grab a single point and relocate it. And at any time, we can switch back over to box mode to get a better understanding of what's going on with the underlying geometry. We're just scratching the surface of what can be done with sub-D modeling, but there is one final command I want to show you, which is subdivide. So if we go up top to this button, subdivide sub-D, in the command line it asks for us to select the faces that we want to subdivide. I'll select them all and press enter. And what Rhino just did is it broke each of the faces into 4 faces, which enables us to then go in and create additional extrusions if we want to, or simply move around the additional faces, edges, and points to get exactly the shape that we're after.
So why might we use a sub-D approach instead of NURBS? In the last video, we discussed how we can't turn control points on for NURBS poly surfaces, making it difficult to build some types of complex organic forms. For example, I chose to use sub-D to create the couch I just showed, and this vase with flowers, because the forms were highly organic, complex, and required continuous surfaces. So, the key points for this video are, first, besides NURBS geometry, we can also work with meshes and sub-D in Rhino. However, modeling with meshes and sub-D introduces many complexities. In the short term, to keep the learning process manageable, I encourage beginners to focus on NURBS modeling. Once you're confident with NURBS, then branch out to explore meshes and sub-D. In this exercise, by building a light bulb, you'll learn some commands for turning curves into surfaces. You'll also learn how to create and manage layers and how to assign colors and materials to layers. To download the exercise file, follow the link in the description.
When you open the exercise file, it should look like this with 2 circles. And over in the layer panel, the only visible layer is loft. So as you may have guessed, we're going to run the loft command to turn these couple of curves into a surface. So we'll select them both and type in loft, L-O-F-T. And it's asking in the command line if we want to drag the seam point to adjust. But the arrows are well aligned here, so we'll just press enter. And we don't need to change anything here. We'll just push OK. And to better visualize the result, let's change from wireframe to shaded mode. Now we want to hide the loft, so we can come over and click on the light bulb next to loft, but nothing happens. And that's because when we created this surface, default was set as the active layer, indicated by that check mark there. And so that's okay. We can create a new layer. We need to do that anyway. We'll right click there and create a new layer, and we'll call this black plastic. And then we can select the surface, right click on black plastic, and go to change object layer. And now if we click on the light bulb, it will disappear. Next, we'll work with the revolve layer. So we'll click on this light bulb. We'll use the lasso to select both of these polycurves, and then we'll type in revolve. And the start of the revolve axis is at the top. We need to temporarily turn our OSnaps on, so I'll hold down the Alt key to temporarily toggle OSnap. And on the left, we want to make sure that the end snap is enabled. And so the start of the revolve axis that's being asked for in the command line will be here, and the end of the revolve axis will be here at the bottom. The start angle 0 is fine. We'll press enter to accept that. And we could use our snap to make it come all the way around. I find it easiest if we're looking for a full revolution to just click on full circle. And then to inspect the result, we can go to right click here and choose ghosted. With ghosted on, we can then better see the surfaces that we just created. Now we need to create 2 new layers, one glass, one metal. And while we're at it, we'll go ahead and create a yellow layer for the filaments part that will be in the center. And the way we can do this is by right-clicking in the layer panel. We'll choose new layer and type in glass. And the trick when you have to create several layers is while the cursor is still blinking there, we can click on the tab key to create a new layer. So we'll call this metal, press tab again, and yellow. And then we can move the glass over to this layer, change object layer. We'll select the metal part, right click on metal, and change object layer. Now we'll work with the pipe layer. So we'll click on this light bulb. We'll select these top two curves and type in pipe. And the pipe radius we want to use is 0.05. So I can simply type that in to the number pad. 0.05, press enter. And it should give you surfaces that look like this. And we want to do the same for the bottom, but we want it to be bigger. So let's select it. We can press enter to repeat the last command that was run. So we'll do that. And then the start radius, we'll type in 0.2, enter. And we could use a different radius for the end here, but we want to reuse 0.2 as our end radius. So we can simply press enter to repeat that dimension. And we'll press enter to complete that command. Now if we turn the metal layer on, we can see that we need to duplicate these things to the other side to make it symmetrical. So we'll select the first item on the bottom, hold shift and click on the top stuff, and then type in mirror. And the start of the mirror plane is the end point here. So I'll hold Alt to temporarily turn my object snaps on. We want to make sure that we have the end snap enabled, and we'll just click on the end, which is the center there. And we want this to be mirrored in a way that is aligned with the grid, so we can just hold shift to temporarily turn ortho on and click here. And then the last thing that we want to do with the top part is I want to bring this filament out a little bit to make it extend just beyond the end of those two pipes. Let's move these metal parts to the metal layer. So we'll use the lasso to select those two, hold shift and click on these bottom ones, and then right click on the metal layer and change object layer. And we'll just turn it off to confirm that that's where the parts went. And we want to put this top part, or actually these top two parts, on the yellow layer. So we'll right click on yellow and change object layer, click the light bulb to confirm that they went there. Now we want to organize our layer panel a bit, and we might be inclined to just select these curve layers and delete them. But I find that it's helpful to keep curves around for future reference in case we need to build some additional geometry going forward. So what I recommend is to right click and create a new layer, and we'll call this Z curves. And then if we select the loft layer and hold control, we can add additional layers to that first selection. Or another thing that we can do is select loft, hold shift, and click on revolve to select multiple layers. But once we have these selected, we'll drag them down onto Z curves. And we've just made them sub layers of Z curves, which enables us then to just click on the light bulb at the top to hide everything. And now that we've done this, because we've put a Z in front of curves, we can sort alphabetically, which will put curves down at the bottom. Now we can turn all of our surface layers on. So we'll select black plastic, hold shift and click on yellow, and then click on the light bulb to turn them all on at once. And we'll need to fix a mistake I made, which is this part needs to be moved down. So we'll bring it down about here, and we'll change to shaded mode. And it's open right now, so we need to cap that by typing CAP. As models get more complex, it can be very helpful to have a different color for each layer. And so the boxes here indicate the color of the layer. Now, black plastic, I think it makes sense to keep this black. But for glass, let's change this. Let's make this into white. So we'll click on this and we'll select white at the top. And for metal, let's choose gray. Sure, gray is fine. And then for yellow, let's choose gold. And if we go to ghosted mode, we can then see how those changes apply to the model. If we change to wireframe, the colors remain the same. If we change to shaded, the colors remain the same. But if we switch over to rendered mode, now the model is entirely white. And that's because Rhino is using the material definitions to determine the color in rendered mode. So let's go ahead and make some changes to the materials. And for black plastic, we'll click on the circular icon in the material column. We'll switch from plaster to plastic and change the color to black. Press OK. And then for glass, we'll select glass. For metal, we'll select metal. And for yellow, let's select plastic and set this to a golden color.
In conclusion, this exercise gave you some practice making surfaces from curves, managing layers, changing layer colors, and adding simple materials, which are all important elements of modeling and rendering in Rhino. In this video, you'll get some practice making 2D geometry, often using snaps to ensure clean, usable results. And we'll also cover some methods for translating the curves into 3D geometry. Along the way, we'll work with a few toolbar submenus so you'll better understand some of the options available in Rhino.
Let's start by looking at a couple of ways we can use the pipe command on curves. We'll first create a polyline by clicking on that button and click about 8 times in the perspective window to create a spiral. And let's do the same thing with a control point curve. And then to make these spirals more interesting three-dimensionally, we'll turn control points on with F10, and let's move some of these central points up in space. Now that the curves are extended up about like this, we'll go ahead and turn the points off with F11. Now let's pipe this left polycurve. We'll select it and type in pipe in the command line, and we're being prompted to define the start radius. So that just means that we need to come in here and click to define how big we want this to be. And just to get consistent results and keep it from giving kind of messed up overlapping geometry, I'll just push enter to repeat the last radius. And it's asking if we want to define some other variation in the radius along the length of it. I'll just push enter though to keep it consistent. Let's do something slightly different with the control point curve. We'll select it and run pipe again, but this time instead of cap equals flat, we'll change it to cap equals round. And let's make it so that the radius is bigger at the start and narrower at the end. And let's make it also so that we'll add another point on here for a radius, and we'll make this one wide as well so that it'll stay wide until about here and then taper out. We can also make a spiral with the spiral command. So if we type in spiral, the start of the axis, let's click here. And because we want this to be similar to the ones that we've done so far, let's go into the front or the right viewport, and we'll go up in space to about here. I'm holding shift to constrain to ortho, and let's go back to perspective. And in the command line, we're being prompted to set the first radius in the start point. So we'll go to about here to define the base of it. And if we want to change the number of turns we have of the spiral, we could set this to be higher or lower. 10 would be too many. Let's go to 2 and see if that looks okay. Now we need to click again to define the end radius. And we can pipe this as well. We can get a similar result by using the sweep 1 command. Let's create a control point curve. Something about like that. And then let's create a polygon. And let's make this a star. And let's make it a round curve. By doing that, it lets us create this polygon so that it will be actually centered on the curve we just made. And I'm going to come out to the end of the curve and click. And then we'll click again. And then we have to click a final time to set the inner radius of the star. Now we'll run the sweep 1 command. It's asking for the rail. That will be the control point curve. And the sweep shape will be the star. And we'll push enter. And we don't need to change anything about the seam point for this. We can push enter and we'll just accept the default settings there. And you could even cap this off because the ends are planar. Sweep 2 is like Sweep 1, but as the name implies, it uses two rails. In our example, we'll use Sweep 2 on some curves over a planar surface. So we will create a rectangle to start off, and then we'll create a circle that is centered on the left edge of this rectangle. So I'll hold the Alt key, we'll check to make sure that the near snap is enabled, and we'll make this first circle fairly big, about like that. Now we'll create the small circle. We want it also to be centered on the left edge of the rectangle, but we want it to begin at the bottom of the big circle. So let's click on the circle button here, and let's select the 2-point option so that we can set its diameter instead of its radius. And I'll hold the Alt key in order to temporarily turn my OSnaps on. And let's turn off the point snap and the center snap and the end snap too, so that we're just left with the near snap and the intersect snaps being on. And then we'll click here at the intersection and we'll come down to about here. And now we'll grab these two circles and we'll use the gumball to rotate them up in space. I'll hold Shift to turn ortho on temporarily, and they'll be snapped vertical like that. Now we want to create 3 control point curves that begin on the left-hand side where the circles meet the rectangle. So we'll click on the control point curve button here. We'll hold Alt on the keyboard to turn OSnaps on. Let's make sure that we have the near snap and intersect snap enabled. And then we can use the intersect snap here. Click a few times and click here with the near snap on the right side of the rectangle. And then we can push the right mouse button to complete that command. And we can also use the right mouse button to repeat the last command we ran. So again, we'll use the intersect snap on the left and the near snap on the right. And we'll do that same thing for the bottom. Now we'll use the Sweep 2 command to create some surfaces. So we'll type Sweep 2. And the first rail is this top curve. The second rail is the lower curve, and our sweep shape is the circle here. So we'll push enter. And for this one, the seam point doesn't really matter, so we'll just push enter. And if we want to get picky about this, we could add a slash to just make the curvature a little bit more regular here. So I'm going to click a couple times to define that slash and push enter. And then we'll push OK. And we'll repeat that process for the lower curves as well. Sweep 2, first rail is this one, second rail is this one, and the sweep shape is this. And we'll push OK. And finally, let's select the rectangle on the outside and run the planar surface command. If our intention were to 3D print this part, we would need to turn these surfaces into closed volumes. So the first step in doing that would be to select these surfaces and run the cap command. And then we could select the planar surface here and run the extrude surface command and bring it down to about here. And finally, we could select all of these closed volumes and run the Boolean union command. And now if we go into ghosted mode, it's easy to see that we eliminated the overlapping surfaces.
Sometimes the sub-options under toolbar buttons can help speed up your workflow. I suggest spending some time familiarizing yourself with the available options. At this point, we'll look at just a couple that are nested under the polyline button. Click the triangle in the lower right of that button to open the submenu, then click the top of the menu button to dock the submenu.
Then we'll create 4 circles. If we need to create a perpendicular line between these 2 circles, one way of doing it would be to use the perpendicular snap in the OSnap panel. Another way would be to use the submenu button here, line perpendicular to 2 curves. So we'll click on that button, and the command line is asking us to select the first curve near the perpendicular point. So we'll click there, and we'll click on the other circle to create that line. In a similar way, if we want a tangent line between these two circles, we could use the tangent snap in the OSnap panel, or we could click on this button, line tangent to two curves. And so now we need to click here on the circle and click on the other circle to create that tangent line. Now if we select the perpendicular line we created before and we hold shift and scale up on the gumball, we can bisect both of those circles, and then we can select everything and run the trim command and get rid of these lines and these and press enter. Then we can join these lines together. It says in the command line 5 curves joined into one open curve. By doing that, we could then select this curve and run the extrude curve command in order to create a surface with 2 perfect half circle indentations. In our next example, we'll look at how the curve Boolean command can help to speed up complex trims. We'll start out by making a rectangle, and we'll click here, and we'll hold shift as we drag out to turn ortho on and make this into a square. And then the next step is to create a circle that is touching at each midpoint of the square. And we can do that by clicking on the 3-point option, and that enables us to then use our mid snaps to snap. Actually, let me turn off the near snap so I don't accidentally snap near. Mid, mid, and mid. Now let's use the trim command to create an interesting shape. We'll select all of this geometry and run trim. And let's cut away the top of the square and the bottom of the circle. And press enter. Now we have this curve and this poly curve, which we can join together. Now we'll offset this poly curve. So we'll select it and type in offset. You can see in the command line that a bunch of different commands come up. We just want the plain old offset command. And we can choose to offset to the interior or exterior. We can also change the distance. I'll set this a little bit higher to 4. And click here to create the offset. And now let's create a circle in the lower left corner, like this. And finally, we can select all of this geometry and run the curve Boolean command. Curve Boolean. And now we click the inside regions we want to keep. So I'll click here, 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 and here. And let's also select where it says delete input equals none. Let's set it to all, which will get rid of the curves that we used to create the final result. Press enter. This is a pretty simple example, but during more complex trim operations, curve Boolean can really help to speed things up. So now that we've finished that step, we can select all of these curves and run the planar surface command to create a surface out of this unique set of shapes. And then we can run extrude surface to turn this into a closed volume. While we're pulling this up, we want to look in the command line and just make sure that solid equals yes. If it doesn't, you would just want to click on that button. Now we'll create an ellipse. And the submenu buttons for ellipse are quite similar to what we've looked at so far. So we'll just show how to make one vertical in order to cover something different. So by clicking on that main ellipse button there and then clicking vertical, we'll then be able to define the center of the ellipse. And I'll hold shift to make it so that this is aligned with the grid. And then we'll choose how tall we want the ellipse to be. Now let's create a couple of arcs. And we could just come up and click on the arc button, and then we would define the center, the start, and the end of the arc. Normally though, when I make arcs, I snap them to existing geometry. So let's create a couple of lines like that. And then let's go to the arc submenu button, and we'll select arc, start, end, radius. And the start of the arc will be here at the end of this line. So make sure that you're holding Alt and your end OSnap is turned on. So we'll snap here, we'll snap to the end of this one, and then we can drag around to define whether we want this to be a concave or convex arc, and we can also define its radius. But if our intention with the arc is to simply create round corners, there is an easier way of doing that. Let's create a rectangle to demonstrate, and then we'll select the rectangle and run the fillet corner command. And then we can enter a dimension if we wanted to have a smaller or bigger radius, and press enter. A final rectangle option I want to mention is 3-point, because I use it often in modeling. So let's create a rectangle. And then suppose that we want to build another rectangle off of the right side of this one. The way that we could do that is by, again, clicking on rectangle, but this time let's select the 3-point option. And this enables us then to, with our end snap, snap to the top and the bottom, and then we can drag out to define how wide we want this to be. Earlier in this video, we made spirals and then piped the curves. Let's do something similar, but this time with a helix. This will give us a chance to talk about adding control points and blending curves. We'll start out by making a control point curve in the shape of a C. And then we'll run the helix command. Let's select the around curve option, and we'll select that C-shaped control point curve. And if we need more or less turns, we can adjust that. I'll set this to 5. And now we have to drag out to define what kind of radius we want for the helix. This looks fine. Now to finish out the helix, we'll run the blend curve command. And we want to select this end and this one. And there are a number of options you can choose from here. Tangency, curvature, G3, G4, that will affect exactly how those curves are blended together. You can also move these handles around to affect the curvature. So we'll press OK once we're happy with the result. Now we'll select these curves and join them together. And let's suppose that we want to further modify the curvature here, but that we don't have enough points here to get the result that we're after. We could actually insert new control points, and we could do that by just simply typing insert control point and then clicking on this curve a couple times and press enter to finish. On the other hand, if we have too many points in our curve, we could select the points that we don't want and push delete to get rid of them. So once we're happy with the result, let's select the curve and run the pipe command and choose the radius. And I'm going to make it so that it varies a bit in its width. And press enter to finish that command. We'll end the tutorial with a few variations on the loft command. Let's start by making a polygon. And then we want to make a copy of that polygon. We'll just tap Alt on the keyboard while dragging up on the gumball. And then we'll scale this down. And then we'll make another copy by pushing Alt. And then I'm going to take the bottom one and move it up, making a duplicate. Again, by tapping Alt while dragging on the gumball. And that looks pretty good. Let's make a couple of copies of this set of curves. So we'll just tap Alt again as we drag over and do that one more time. Now we'll select all of these curves and run the loft command. And it's asking in the command line if we want to drag the seam point to adjust. Because the seam point is well aligned among all of the curves, and because the arrows are all going in the same direction, it looks good. If we would need to change anything about it, we can click on these arrows actually, or we can even move these points around in space. But again, I'm going to put this back and switch the arrow back to the previous direction and push enter. And in the context menu, we now have the ability to change the style, but let's keep it at normal the first time. And let's do the loft command again, but this time we will change the style to straight sections. Another way that we can get a different result with the loft command is by simply swapping out the polygon with some other shape. So let's click on polygon and then click on star in the command line. It's asking for the center of the star, so I'll hold the Alt key to turn on OSnaps and make sure that the center snap is enabled. And that lets us then define the center of our new geometry based on the polygon. And it's asking now in the command line for the corner of the star, so let's snap to the end here. And it wants us to now define the second star radius, so we'll pull into about there and click. And now let's delete this polygon, and we'll select this geometry and run the loft command. And the seam point looks fine, so we'll press enter. And let's change this to normal and press OK.
In this tutorial, you learn techniques for creating and modifying 2D geometry while leveraging snaps and toolbar sub-options to get clean results efficiently. We used commands like pipe, sweep 1, sweep 2, extrude, and loft to generate 3D forms from the curves. Understanding these methods should significantly improve the efficiency and quality of your modeling projects. In this video, we'll briefly discuss ortho, nudge, grid snap, and planar snap, which are all types of modeling aids in Rhino. In previous videos, we've already used the ortho feature several times. Again, ortho constrains movement to orthogonal directions, meaning it restricts movement to right angles or perpendicular paths. So by default, it's set at 90 degrees, but I usually set it to 45 degrees.
We can do that by coming up to the standard panel at the top and going to the yellow gear here for the options. And then we'll go down to the modeling aids section. And we want to change this option here, ortho snap every 90 degrees. So we'll click this box and we'll set it to 45. And while we're here, I recommend unchecking this box for ortho snap to C-plane Z, because I think that this gives some odd behavior when you're working in perspective, where it's possible if you're drawing a polyline for it to accidentally go vertically in space when you may likely want it to go to the construction plane. So these are the settings I recommend. Now we'll go back into the perspective window. And again, the way that I usually like to use ortho is I keep it turned off and then I hold shift when I want to turn it on temporarily. So let's create a polyline, and we will click once and then we'll hold shift to temporarily turn ortho on, and then we can click and obtain both the 90-degree angles that align with the grid, and we can get these 45-degree angles. And similarly, if we rotate an object, we can get it to rotate to 45-degree increments. Now we'll take a look at nudge. But to do this, we'll need some geometry that we can move around. So let's go up to the solid creation panel, and we'll click on the triangle in the lower right to open up the drop-down. And let's create a sphere. And then we'll go to the top viewport, and let's create a tube now. So we'll again open up that solid creation panel and select this option. And I'll use my my center or end snap to grab the center of the sphere. And then we're defining the first radius, so we're defining the interior right now. I'm going to make this just slightly bigger than the sphere. And then we'll define the outer radius like that. And then we need to go to the perspective window to choose how tall we want this to be. Something like this will work fine, so that the tube is just slightly bigger than the sphere. Now what I'd like you to do is to take the sphere and move it off to the side, move it up in space, and then I want you to move the sphere back into the center of the cylinder using nudge. So if you select the sphere and push the arrow key up and down, you'll see that our view changes, or left to right, our view changes again, or page up, page down, we go forward and backward. So this is not what we want. We want to come up to the yellow gear again, expand out the modeling aids section, and then click on nudge. And we want to set the nudge keys to work with just the arrow keys alone. And while we're here, notice that we have nudge steps. So if we're using the nudge key alone, it's going to give us a 0.2 inch movement. If we do Control plus nudge key, it will give us a smaller movement of 0.05. If we do Shift plus nudge key, it will give us a really big movement. Now that we've made this change, we can select the sphere and push the arrow keys, and we will be able to move that sphere back toward the center of the cylinder. Or if we hold Shift and push the arrow keys, we'll have a large movement toward the center. Or if we go back up to the top view, we can even hold Control to get a smaller movement. And we should also mention page up and page down. So if we go to the side like this and push page up, page down, we can see that we're moving the sphere vertically. I use nudge quite a bit when I'm modeling, especially with the Shift key. I'll set this increment up to be quite high so that then if I need to temporarily move a part out of the way to get access to something underneath, it's very easy to do that, and to know also that I can get it back exactly where it was just by shift nudging a few times. Grid snap is another useful tool to know about. So if we click on this button, we can then create a polyline that snaps to increments on the grid, or we can create boxes of even units of measurement. And so as we draw these out, notice that the grid snap is applying not only to the width and the length of the boxes, but also to the height. Now let's talk briefly about planar snap. If we want to build some curves off of the top of this box, we can create a polyline, we can snap to the corner with the end snap, and we can drag over to build what appears to be a curve extending off in space at the same height as that top corner. But when we complete that command and we orbit to the side, we can see that that curve actually goes down to the construction plane. And that's because by default, Rhino puts things on the construction plane. But a way that we can override that is by turning planar on. And so now if we do the same thing, we create a polyline, we snap to the corner, and we drag off in space, and then orbit, we can see that it does stay at the same height that we intended.
In short, modeling aids like ortho, nudge, grid snap, and planar snap can help you build and move geometry more effectively.
In this short video, we'll take a look at how construction planes work. To illustrate the impact of which construction plane is active, we'll go over the project command, and we'll cover a command called project to C-plane that's used for flattening geometry. Note that at times in the video, I'll refer to C-planes. This is just a short name for construction planes. To get started, let's open up the 4-viewport layout. And the first point we should cover is that each viewport has a different default construction plane. So what this means is that depending on which viewport you're working in, you'll get a different result when you create and modify geometry. So let's look at some examples together. Let's open up the solid creation panel by clicking on the triangle in the lower right, and then we'll just bring this open to dock it. And notice that if we click the cone button to create a cone and we move into the perspective window, the icon in the top left corner turns blue. That's Rhino's way of telling us that the perspective window is now active. So if we click somewhere and then we create a cone that has a radius of 10, so I'll type in 10, and an end of 20, that will give us a cone that is based on the ground pointing up. And it drew the cone in this way because in the perspective window, our default construction plane is XY. Now, if we go into the top viewport and do the same thing, make a cone that has a radius of 10 and an end of 20. And by the way, you can push enter, enter to just repeat the last dimensions that we used. We get the same result. So again, the cone is on the ground facing up. And that's because in the top viewport, the default construction plane is XY. Now, if we, on the other hand, go into the front viewport and create a cone, again with the same dimensions of 10, 20, now the cone is based on the ZX construction plane, which makes it so that it's sideways in space. And in a similar way, if we go into the right viewport and create the cone again with the same dimensions. So I'll click and push enter, enter. It is now based on the ZY construction plane. So this example shows simply that depending on which viewport you're working in, a different construction plane will be active, and that will impact how geometry is created. Now we'll take a look at another example using curves. Let's go into the perspective window, select all of the cones and hide them. And let's maximize the perspective window. And let's draw an X. So we'll make one polyline like that, and we'll make another one like this so that they overlap clearly. And now let's run the trim command. And for the cutting object, just select one of the lines and press enter. And now it's asking for the object to trim, so let's select half of the other line and press enter. In this case, Rhino didn't need to use the active viewport or active construction plane to run the trim command. There was a physical overlap between these two lines. On the other hand, if we go back to the 4 viewport layout and we go into the right viewport and create a control point curve like that, and then we go into the top viewport and create a polyline that intersects that squiggly curve we just created. And we'll run the command again, trim. And here we'll select for the cutting object the straight line, press enter. And for the object to trim, let's try to select the curvy line. And again, it fails because the two lines don't physically overlap, they don't touch. Now, if we turn apparent intersections on, set that to yes, now we're able to then select half of that squiggly line to get rid of it. And that's because this command, trim, if you're dealing with geometry that doesn't physically touch, it is going to be viewport dependent. Just to show one more example of how this works, we can undo the trim command. We could go back into perspective, and we can run the trim command again. So the cutting object, again, is this straight line. Press enter. And the object to trim, let's select the curve here. And notice that because apparent intersections is turned on, and we are looking at the overlap between these two pieces of geometry, just depending on our angle in this viewport, we're going to get a different result. So if you're just looking to make a quick and dirty trim to a curve, this can be a fine solution. But if you are going for a more precise intersection between the two curves, then it's better to either use the top viewport or to physically extend this into a surface so that when you run the trim command, you can turn apparent intersections off. And then, we do have this actual intersection between the two objects to use for the trim. Now we'll take a look at the project command, which is also viewport dependent. So we'll bring the cones back by typing show. And let's go into the front viewport. I'll maximize it. And I'm going to create a control point curve and make it squiggly in a way that overlaps these cones. Okay, and now we'll run project. So the curves to project are this one. We'll press enter, and then we'll select the cones and press enter again. And now if we go back to the perspective window, we can see the result. And of course, if we were to select this curve and turn it 90 degrees and go into the right viewport, if we run the project command again, we're going to get a very different result because it would be throwing this curve onto the cones from a different vantage point. A similar command called project to C-plane can be used to flatten out curves. Let's go into the perspective window and create a circle. We'll make it deformable, and we'll make sure that degree is 5 and point count is 10. So we'll create it here. Because we have a closed curve that is totally flat, we could select it and run planar surface to create a surface. But if this circle were to have some points that went up into space so that it's no longer flat, then planar surface would fail. You've likely seen in some of our other videos that we can select this curve and use the gumball to flatten it out, but we'll never get it quite perfect. So if our objective is to run planar surface, we really need to use the project to C-plane command. And so if we go into the top viewport and run that command, project to seaplane, and we'll set it to not delete the input object, just so that we can see the two side by side. Now we can select the lower curve we just projected to seaplane to get the command to work, planar surface. To reinforce the concept of viewport dependency, we could go into the front viewport and project the seaplane from here. And now it's thrown that closed curve onto the ZX plane.
As we wrap up, you should also know that there are many ways of relocating the construction plane. If you want to research custom seaplanes on your own, right-click on the viewport name in the top left, and then go to Set Seaplane and explore those options. And of course, you could also experiment with turning Auto Seaplane on at the bottom of the screen. However, I don't use these custom seaplane options because they tend to confuse me when I'm modeling. But who knows, maybe you'll try them out and find them helpful. Regardless, the main ideas I want you to take away from this video are that each viewport has a default seaplane that impacts the result you'll get when creating and modifying geometry, and some commands are viewport dependent. We'll start this video by talking about command shortcuts. To download the exercise file, follow the link in the description. In Rhino, there are many different ways to execute commands. Let's look at 4 different ways of running a new command, then 3 ways of repeating commands.
While introducing these command shortcuts, we'll also take a look at some of the solids that we haven't yet created. So let's open up the solid creation panel and dock it here. Let's first create a paraboloid. And here we're doing it with the button in one of the toolbars. Another way that we can run a command is by typing the name of it. And so if we want to create a truncated cone, we can type that name into the command line and then follow the prompts in the command line to create it. A third method for running the command is to use the menu button. So if we want to create a pyramid, we can come up to the solid menu button and then come down to pyramid and then build it. A fourth way of running the command that we haven't covered in previous videos is with the middle mouse button. So if we click that button, we have a pop-up menu. So if, for example, we click on explode, we could from there run the explode command. Now we can customize this middle mouse button menu by clicking it and then docking it, and then we can drag over a command that we want to run. So if for example we knew that we wanted to create a bunch of truncated pyramids and we want to have a quick way of accessing that command, we could hold Control and drag that button over from the solid creation panel into our middle mouse button menu. And then we could close this, and then the next time we click the middle mouse button, we are able to then run that command. It's important to know that when we dragged the button over into our middle mouse button menu, we held Control, not Shift. If we hold Shift, it will actually move the button to the new location, and it will reconfigure our solid creation menu. So that could be a source of some distress later on if you go back and are looking for that button later. So again, to create a copy of the button in your middle mouse button menu, you want to hold Control when you're dragging it over. Now, on the other hand, if you want to get rid of a button anytime from your pop-up menu, hold Shift and drag it out to delete it. And we have several ways of repeating the last command we ran. So if we push the space bar, it will run the truncated pyramid command. If we press the Enter key, it will do the same thing. It will repeat the last command. And the right mouse button will do the same thing, repeat the last command. On the other hand, if you want to call up a command that you ran a few minutes ago, you can do that by right-clicking in the command line, and then you'll find a clickable list of all the commands that were run in the recent past. Now let's talk about methods of selection. You know from previous videos that we can select an item, hold Shift, and click on additional items to add them to the selection set. And we can also then hold Control and click on items to remove them from the selection set. And we can use the lasso to select items, and we get a different behavior with the lasso if we go from left to right, in which case only those items that fall totally within the lasso will be selected. Or if we go from right to left, everything that the lasso touches will be selected. When you're modeling a complex project and you get into the later stages, you might be in a situation where you want to select all geometry that belongs to a specific type. So for example, if you're at the stage with a model where all of your parts have gotten to be either surfaces or solids, you might then just want to select all of the curves and get rid of them because they were just there for planning purposes. So in that case, there are a few ways that we could get rid of the curves at once instead of just having to go around and click on each individual one. One way to do this would be with a menu button. So if we come up to Edit and go to Select Objects, we could then come down to Curves, and it will select all of the curves in the scene. If you prefer to do your selection with a button, you can do that by coming to the Standard panel, come over to the Select drop-down, and then click on the Curve button. I often find that it's faster to just type the name of the command. So if we type in SELCRV, that will give us the same selection. A few other common selection commands are Cell Point, so SELPT, or SELSRF, which is Select Surface, or Cell Polysurface. Sometimes when you're modeling a complex project, you can accidentally make copies of geometry that are exactly overlapping in space. Now, if you want to get rid of those copies, you could go through the selection menu and select each of them and delete them on their own. But there is a faster way, which is to run the cell dupe command. So SELDUP, and then you can delete all the duplicate geometry so that you're left only with one copy. Another command that I use a lot is cell last, and that will select the last piece of geometry that you made or modified. So if we make a box and click away from it and then type cell last, it will select the box. When we're modeling in Rhino, we want to make sure to create geometry that intersects with other geometry in the way that we intend it to. So an example of how this is important is if our intention is to join this line to this line, just drawing the lines together without the snaps isn't going to enable us to then join those parts together. Because they don't exactly meet end to end. So if we run the join command on this stuff, it will fail. Similarly, if we were to take the geometry that was drawn incorrectly and extrude it up into space, we then have a couple of surfaces that don't quite meet up at the end that couldn't be joined together. So this illustrates why it's so important to make sure to use an end snap in a case like this. And in a similar way, if our goal is to, say, snap to the intersection of something or to snap at the quadrant of something, we have means of doing that with the OSnaps. You've seen in my previous videos that my tendency is to keep OSnaps turned off and then hold Alt when I want to temporarily turn them on. But in this case, we'll be doing a lot of OSnaps, so let's just click this button to make them active by default. And then we want to make sure that all of these boxes are checked except for project. And that's because we'll be making a polyline, and we want to make sure that when we click on a vertex here, that it actually snaps to the vertex itself. If project is clicked, it will actually project that point of the polyline down to the construction plane. And now we'll go up to the polyline button and we'll snap to the end of this line for our first point on the polyline. And then we want to snap near on this line. Near will let us snap really to any point on this line. And then we want to snap to this point and then to the midpoint of this line. And be careful to pay attention to the tooltip. It's showing us that this is the perpendicular snap and this is mid. And then we want the tangent angle on this curve, which is here. And then we want the perpendicular angle on this curve, if we can get it. Perpendicular, there. And now we want the intersection of these two lines. And then we want to get to the center of this circle. And we can do that by mousing over the circle itself. And then we want the quadrant of this circle. So you could get that at the top, the left side, the right, or the bottom. Quad, there we go. And now we want the knot of this cone right there. And we want to snap to one of these vertexes. and we can right click to complete the command.
This video covered command shortcuts, selection methods, and OSnap options. While some of this content was more basic than previous videos in this beginner's course, it's important to know these fundamentals so you can work efficiently in Rhino. In this video, we'll dive into advanced techniques for rotating, scaling, splitting, trimming, and joining geometry.
If we want to open up this hinge 90 degrees, we can do that with the rotate command. So we'll type in rotate. In the command line, it's asking for the object to rotate, so we'll select this part of the hinge and push enter. And we'll define the center of the rotation as the center of this pin. So I'll hold Alt to turn on my OSnaps. I have the center snap enabled. I'll click there, and then I'll come over this way and I'll hold Shift to constrain orthographic. And then we'll go up to define the second reference point. We'll hold Shift again and click. And so there we've opened up that hinge 90 degrees. Now, that's a pretty simple example. What if we have a hinge that is laid back in space at an angle like this? What do? If we use rotate here, we'll do the same command. Select object to rotate. We'll select that part, press enter. We'll define the center of the hinge as the center of our rotation and click back 90 degrees. And now it's no longer in alignment with the other part of the hinge. So we need a different solution. So let's undo that, Control Z, and let's instead run the rotate 3D command. So the object to rotate is this. Now for the start of the rotation axis, we'll again snap to the center of the pin on this side. But we need to actually define now the end of the rotation axis. So we'll come down and select the bottom of that pin. So we'll again use the center snap here. And for the angle or first reference point, let's get this lined up with the grid this way. And we'll snap again with ortho this way. So using rotate 3D is a much better solution in situations like this where the object is not entirely aligned with the grid. Now let's turn on the scale layer. And the first thing we'll do in this section is use the gumball to scale this box to be the same height as the neighboring geometry while keeping the bottom where it is. So the easiest way to do this is to hold Shift and Control and do a sub-selection on that top surface and then drag this up to make it match as best we can. We could go into the right viewport, really try to get this dialed in. But if we zoom in, we can see that it's still not quite right. So I'll show you an easier way. Let's run the scale 1D command. So we'll just type that command in to the command line, scale 1D. The object to scale is this cube, so we'll select it and push enter. And now we're being asked to define the base point. So we'll just use our end snap and click here. For the scale factor or the first reference point, we'll use our end snap again to click here. And for the second reference point, let's come up and use our end snap here on the neighboring piece of geometry. So this is a much faster way of getting this part to scale up to be the height of its neighbor. If we want to scale this box up to fill in this entire empty area without getting any taller, the easiest way of doing that is with the scale 2D command. So we'll just type that command in to the command line, scale 2D. The object to scale is this. The base point is here. We're using the end snap again. The first reference point is here, and the second reference point is here. Again, we're using the end snap. On the other hand, if we're starting with a cube and we want to scale it up to fill a cube-shaped hole, we could do that with the scale command, which scales uniformly. So we'll type in scale in the command line. The object to scale is the cube. The base point is here. The first reference point is here, and the second reference point is here. Now let's turn on the split layer, and we'll look at a couple of simple examples first. So if we want to split this curve on the left with the point, we could select the curve as the object to split and push enter, and then the cutting object can be this point, and we're left then with two curved segments. Or we could split this surface with the curve because they're laying on the same plane, so split. The object to split is this, the cutting object is this, and now we have two different surfaces. And even if this curve were moved up in space, we could still get the split command to work on a surface like this if we were to go into the top viewport and use apparent intersections. But if we want to split a piece of geometry up in a way that can't be achieved with apparent intersections, we may need to interpolate a curve onto the surface and use that for the split. The way that works is we'll go up to the drop-down menu for the curves and select Interpolate Curve on the surface. And the command line is telling us to select the surface to draw on, so we'll click on this sphere. And then we can start to create whatever kind of curve we want that snaps in various places on the sphere. And we just need to make sure that we come all the way back around to end where we started. To snap back to the point we started from, we'll hold Alt to do our end snap, or a point snap here, and push the right mouse button to finish the command. And now with our closed three-dimensional curve on the surface, we can run the split command. Select the object to split, which is the sphere. Select the cutting object, which is the curve. And it's broken into two parts. A final split example we'll look at here is between this curve, which is offset from the surface, and the sphere. And so if we run split, and the object to split is the sphere, the cutting object is this curve, I guessed when I first tried this out a few years ago that this command would fail because we're working in the perspective viewport, the curve is not touching the sphere, and we're not using apparent intersections. But if we complete the command, you can see it does actually work, and the cut is aligned with the curve all the way around. So it's not projecting from a particular viewport. What must be going on here is that Rhino is using surface normals to define how to make the split. So I won't get too lost in the technical weeds here, but basically if we select this box and we type in dir, it lets us visualize the direction of the surface normals. The normals are vectors that point outward perpendicularly from the surface all the way around. And normals are used for things like shading in the CAD program and also for extrusions. But all this is to say that it's just interesting to note that there are some edge cases where you can get the split command to work without apparent intersections or physically touching. Now we'll turn the trim layer on and we'll turn off the previous layers that we worked with. And from here, we'll look at some simple examples with trim. So if we run the trim command, we can select the circle and the rectangle as our cutting objects, and then we can trim away parts of the rectangle with the circle and parts of the circle with the rectangle. And because this curve and surface are in exactly the same plane, we can trim the surface with the curve. So if we run the trim command, this can be our cutting object, and this can be our object to trim. As you know from previous videos, if we want to trim these surfaces with these curves, we're going to have a difficult time doing that in the perspective window because we would have to use apparent intersections, and then the nature of the intersection will vary depending on our point of view. So that if we want to get the trim to work correctly, we'd be best off going into the front viewport. And now if we run trim from here and use the curves as our cutting objects, we can then select the surfaces to trim them away, except this last one fails. And that's because this curve stops short of the edge of the surface. So let's press Enter to finish that command. Then we can select the curve, press F10 to turn the points on, move this point up in space so that it goes beyond the edge of the surface. And now because our curve fully breaks this surface into two parts, the trim command will work. So if we press F11 to turn the points off and run the trim command, the cutting object is the curve, and the surface can be trimmed away. Now let's turn the join layer on, and while we're at it, we can go ahead and turn the previous layers back on. In this layer, we'll take a look at a couple of simple join examples, and then we'll take a look at a more complex trim and join situation here. So if we zoom in on this geometry and take a look at the parts that make it up, we have two overlapping curves. So if we select the two curves and run the join command, it says in the command line, unable to join curves. And that's because the curves overlap. They don't meet at their ends at a common point in space. Let's look on the other hand at these curves. We have a series of curves that meet at a common point in space in the center. So if we select them all and run the join command again, it says in the command line 4 curves joined into 2 open curves. So if we look at the result, we have these 2 overlapping curves. So why was it that Rhino didn't join all 4 of them up into a single curve? It's because, in addition to the requirement that the curves need to meet at their ends at a common point in space, we can only join 2 curves together at any one location. And now that we've reviewed those rules about how the trim and join commands work, let's look at a simple example here. What I'd like you to try to do on your own is find a way of joining this surface to this one. What do you have to do to make that happen? Go ahead and pause the video and see if you can find a solution. There isn't a really perfect, straightforward solution to this problem, and there are many possible solutions, but I'll show you the easiest one I came up with in the couple minutes I thought about it. I think what we want to do is take this surface and first make it a bit wider. And now what we'll do is select them both and type in intersect. And this will give us a curve at the intersection between the 2 surfaces. And now what we can do is draw a polyline from the end of this curve out to the side. And we can do the same thing over here. And then we can select this curve, this one, and this one, and we can trim this surface. And then to tidy this up a little bit, we'll make another polyline here that goes out this way, and here that goes out this way. Whoops. And then we can use these curves to trim the surface again. And finally, we can run the trim command again, and we can use this surface as our cutting object and trim away the top of that vertical surface. The point of this example was just to show that beyond understanding the basic rules of how trim and join work, we also need to sometimes do a few intermediate steps to be able to join a couple of different surfaces together.
The methods we've covered in this video for manipulating geometry have been very important in my own Rhino modeling projects. I hope you found this content helpful. This video covers Booleans, fillets, and chamfers, which are all types of solid editing commands.
Let's start out by making a cube. So we'll click on the box button, we'll click anywhere in the workspace, and then to set the length, we'll enter 5, and let's press enter again to use 5 for the width, and press enter again to use 5 for the height. Now if we zoom in on this box, what I want you to do next is to create a sphere. So we'll click on the drop down here, select sphere, and let's select 3-point, and I'll use my OSnaps with the mid snap enabled and snap to the midpoint here, to this midpoint, and to the midpoint over here, so that we have a sphere in the center of the cube. Just to make the results a little bit more interesting, I'll scale down the sphere just a bit like that. Now let's make 3 copies of this geometry. I'd like to do this the easiest way, so I'll use array linear. So we can just type that in, array linear. And for number of items, let's set this to 4. So if it doesn't say 4, you can just click here and enter 4. For the first reference point, we will use our OSnaps and snap to the end of the box there. And then we can hold shift while dragging to the right to make our copies. Before we get started with the Boolean commands, I should mention that these commands are meant to be used on solids. So that means you need to work with either surfaces or poly surfaces that are fully closed up with no holes. If you were to attempt to use Boolean commands on open geometry, the command might fail or you might get unexpected results. We'll start with a Boolean union command. So we can type that in, Boolean union, and we'll select these 2 items and push enter. And it doesn't look like much has happened, but if we set this to ghosted mode, we can see that what has just happened is the overlapping parts of the sphere and box were trimmed away, and it was joined up into a single unified solid. Now we'll switch back to shaded for our viewing mode and go over to the next pair. And this time we'll use Boolean difference. The first prompt in the command line is to select surfaces or polysurfaces to subtract from. So we'll select the box and push enter. And now we'll select the sphere and push enter. And so what Boolean difference did was it used the sphere to make a hole in the box. So it made a sphere-shaped hole in the box. Next, let's run Boolean intersection. So the first set of surfaces can be the sphere, push enter, select the box, push enter. Boolean intersection gives you a trimmed and joined result that matches the intersecting areas of the two pieces of geometry. If you're ever unsure of which Boolean command you might want to use, you can run the Boolean toObjects command. And that will let you select the two objects that you want to Boolean, and then left-click to iterate through the different possibilities. Next, we'll talk about fillets and chamfers. Let's select these items and move them back to make room. And then we'll make a new box down here. Let's use 5, 5, 5 again. And then let's select the box, Control-C, Control-V to make a copy. And we'll scale this in uniformly, about like that. And then let's scale one-dimensionally so that it extends beyond the edge of the box like that. And then Control-C, Control-V to make another copy and rotate it up 90 degrees. Control-C, Control-V again and rotate it 90 degrees this way. And now we can do Boolean difference. We want to subtract from the central box with these pieces of geometry around the sides to create a form like this. If we were to 3D print this part, these edges would be sharp. It would be uncomfortable to hold the item. So it's very common for manufactured items to have a filleted edge or a chamfered edge, and we'll look at both of those possibilities. So let's take our part and make two copies of it. So we can run array linear, and we'll set it to 3 this time. The first reference point is here. We'll hold shift and drag out like that. Let's start out with the fillet command. So we'll type in fillet. And note that in the command line, we have many different possibilities. The one that we want is fillet edge. That will work for solids and for poly surfaces. So the edges that we want to fillet, we'll go ahead and select all of these and push enter. And now let's make sure that we have preview set to yes. And we want link handles to equal yes. So if it says no, just click on that to switch it. And let's go ahead and set all. I want you to see what can happen if the fillet radius is too great. So with preview turned on and the fillet radius cranked up to 1, we're getting these wild results where these surfaces are extending way off of the original geometry. That's because the radius we're putting on there is so great that it's causing a lot of self-intersection problems. So we need to turn this down to be something more reasonable. So let's click on Set All. And we can set this to 0.1 in this case. With link handles set to yes, if we don't like this result, we can come in and actually drag this around, drag any of the handles to affect all of the other handles. If link handles were turned off, you could independently adjust each of these different radiuses. So once you're happy with the result, you can push enter. And I would recommend when you run a fillet command to check carefully all of the edges, because it's pretty common to end up with holes in the geometry, and then you might want to go back and redo with a different setting for the radius. Now let's run the chamfer edge command. Chamfer, so C-H-A-M-F-E-R, edge. And the edges to chamfer are these. And let's see, we'll press enter to accept that. And let's link the handles, and let's turn preview to yes. And we can set all to maybe, I think 0.2 is what we did for the fillet, so that should work here too. And that looks fine. We'll push enter to accept.
In this video, we'll cover arrays and flow commands, which can be used to repeat geometry in various controlled ways. Then we'll work with methods of transforming geometry like twist, bend, and cage edit. These powerful tools will help you create complex, dynamic forms with precision and flexibility. To download the exercise file, follow the link in the description.
When you open the exercise file, it should look like this. And the first command that we'll do here is array linear, which you may remember from our last video. So we'll go over to the left cube here. We'll select it and type in array linear. And for number of items, set this to 5 or 10. For the first reference point, let's hold Alt to turn our OSnaps on. Make sure the end snap is enabled. And we'll click here at the bottom right corner. And then hold Shift to turn ortho on and create our copies. Next, we'll run the array command. So we can type in array. We'll select the object to array as this box. For number in X direction, let's set this to 5. Let's set Y to 5 and Z to 5. Now, when it gets to this prompt here that says unit cell or X spacing, what I want you to do is hold Alt to turn our OSnaps on and make sure the end snap is enabled and click at the bottom left corner. And then we'll go over to the point. Make sure that your point snap is enabled. Hold Alt to use your OSnaps and click on the point that I've provided here. And then we'll have to set the spacing along the Z axis. So we'll drag up and click again. And we get this pink preview that shows us what it's going to look like. If you wanted to adjust the spacing, you could do that by clicking on these dimensions here. But we're just doing this quickly for demonstration, so I'll go ahead and push Enter to accept. Now we'll do array polar. So let's type that in, array polar. The object to array is the sphere, so we'll select it and push Enter. For the center of polar array, let's use the center of this cylinder here. So I'll mouse over the edge with the center snap turned on, holding Alt to enable OSnaps. And now for number of items, we'll set this to 10. For the first reference point, let's line up with the sphere. So I'm just going to mouse over it and hold Shift to constrain orthographic. And then we'll come all the way around and click again. And again, we have a pink preview showing what it will look like. You could click on any of these things to adjust them, but we'll go ahead and push Enter to finish that command. Let's move on to the next layer, which is called array curve on surface. So we will type in that command, array curve on surface. And so the object to array here is the cube. And we'll push Enter. Now for the base point, what I want you to do is select this lower left corner. So I'm holding Alt to turn OSnaps on and clicking with my end snap on that bottom left corner. Now for the curve on surface, I'll click on this one here. And for the surface, we'll click on this surface. Now for position, objects, or distance from last, there are fancy ways of using this, using divide or multiple. But let's use the most simple, straightforward version of this command, which is to just click on the curve to make our duplicates. So we can repeat several copies of this cube along that curve on the surface. Let's move on to the next layer, which is called array surface. And so we'll type that command into the command line, array surface, array srf. The object to array is this box. We'll push Enter. For the base point, again, let's use the lower left. So I'm snapping to the end point. And now it's asking for the reference normal. We can just push Enter, though, to use the C-plane Z-axis. Now we're being prompted to select the target surface for array. So let's select this one. And for the number of elements in the surface U direction, let's enter 6. And for the number of elements in the V direction, let's enter 12. And this is the result. Next, we'll move on to the flow along surface command. This will be similar to the last one that we did, except that the boxes, in addition to being put onto the surface on the right, they'll be stretched out based on the curvature of the surface and its width and length. So we'll type in flow along surface. And the objects to flow along surface are these boxes. So select them with your lasso. We'll push Enter then. And for the base surface, let's select the front left lower corner here. And for the target surface, again, we'll select the front left lower corner. And you should get a result that looks like this. If the boxes go to the underside, just know that the command can be a little bit glitchy sometimes, so I would just repeat it again and it should work correctly. Now we'll move on to the history and flow layer. And this is an example from one of my own projects that I made years ago where I created an ant. And I knew that I wanted the antenna to look like this, but I wanted for it to be curved through space like it is on an actual ant. And getting it to match up to this line so that the break between this section and the later part would occur at just the right spot was kind of tricky. Anyway, we'll do this together so that you can see how it can work. The first thing we need to do is to turn history on. So we'll type in history and let's set record to yes. We'll click on that. Update yes. Lock yes. Broken history warning yes. And record annotation history yes. And now we'll push enter. Next we'll orbit over to the side and we'll run the flow command. And the objects to flow along the curve are these surfaces. So I'm going to use my lasso from left to right to select all these things that are totally within the lasso and push enter. For the base curve, let's select this one on the left side. And for the target curve, we'll select the far end of the antenna here. Now, because we have history turned on, we can adjust the relationship between this curve and this geometry in order to affect how it shows up here. So let's scoot this over to the right a little bit. And you'll see it update in a second. Move it over a bit more. And that looks pretty good. Now we'll move on to the history layer. And what I'd like you to do here is select this half of a sphere and run the mirror command. And for the start of the mirror plane, let's use our OSnaps to select the ends down here. And then I'll hold Shift to turn ortho on and click here. A key point that we should know about how history works with the particular settings that we entered is if we select this right half of the now complete sphere and push F10, you'll see that we can't move these control points around. And that's because when we turned history on, we set lock to yes. And since we made this right half of the sphere with the mirror command while history was turned on, it is now subject to history. If you were to need to relocate this right half of the sphere or directly modify its points, you would need to turn lock off, which would break the history too. Just know if you ever aren't able to move some points around or move an object, it could be because history is playing a role. I would say to look in the command line and you should see an indication of what's going on. With history turned on, we can push F10 and we can go to the points on the original half of the sphere and we can move these around. So if you ever need to make a symmetrical object, using mirror with history can be really helpful. Keep in mind that if you leave history on for a while, it can increase your file size considerably. And so I recommend whenever you're not using it to turn it off. So let's type in history to call up the settings again and set all of these to no, and that will turn history off. Now we'll move on to the final layer, twist, bend, taper, cage edit. Let's go over to this left box and run the twist command. So the object to twist is the box. We'll select it and push enter. For the start of the twist axis, just use this vertical line with the end snap to grab the very topmost part of it and use the end snap again on the bottom of that line. So for the angle or the first reference point, it doesn't really matter. Click anywhere and then drag around and click again, and it will twist that geometry along the axis. Now we'll do a bend on the cone, and note that I've gone into the right viewport. So we'll run the bend command, and the object to bend is the cone. We'll press enter. The start of the spine is the bottom of this line here, so I'm using my OSnap to grab the bottom of it, The end of the spine is the top, and now we can drag the spine around to bend that cone. Now it's kind of almost like springy, this spine that it gives us, and so I would play around with it some so you can see kind of the different result that you'll get based on like whether you keep the end of the spine close to the cone or move it more far away. It'll give you more of a gradual result. Let's stay in the right viewport and run the taper command. And the object to taper is the sphere, and the start of the taper axis is the line here. The bottom is the end of the taper axis. And so now for the start distance, we'll go a little bit beyond the end of the sphere. And then for the end distance, let's bring it in a little bit beyond the sphere so that we end up with an egg shape like this. Now we'll go back into the perspective viewport and we'll do a cage edit on this series of spheres that are connected together. Let's type in cage. Oops, actually let's pre-select this item and then type in cage. And so for the first corner of base, let's select bounding box. That will give us a box that encompasses the entire thing. For the coordinate system, we can just use world. We'll push enter. And for the cage parameters, we'll set X, Y, and Z point counts to 4. So now we can push enter. Nothing significant has happened yet, and that's because we still have to assign this item to the cage. So let's type in cage edit. And for the captive object, we'll select the series of spheres and push enter. And for the control object, we'll select the box. For region to edit, global is fine, we'll push enter. And now we can move these points around to transform the object. So we can simply move them to the side, or we can select them and use gumball to scale them up. Or we can even twist parts. So if we select all of these points and rotate the gumball, we'll get a pretty dramatic result there. As long as the cage is active, you can't select your captive objects. So when you're eventually happy with your edits, you can push F11 to turn the points off, and then you can select the cage and delete.
Now that you've learned how to use arrays, flows, and transforms, you can apply the commands to create more advanced designs. The methods we've covered in this video can take some practice to fully internalize, but are worth the effort because they open up endless possibilities for manipulating geometry in creative ways.